Hello and welcome to Vidya Embedded channel, and also welcome you to the series of video tutorials on getting started with TIRTOS kernel. Okay, so in the last tutorial we have seen what is an RTOS and what are the different features that one particular RTOS should provide. Okay, so in this tutorial we are going to see what are the different features of the TIRTOS. Okay, so the TIRTOS is also called as a SYS BIOS. Okay, so either you can call it as a TIRTOS or you can also call it as a SYS BIOS. Okay, so in the documentation also you will see it as a sys bias. Okay, let's move on. TIRTOS kernel features. Okay, so as I said, so TIRTOS kernel is a preemptive scheduler. That means it guarantees the highest priority thread is running. That means so the kernel which is provided with the TIRTOS will always gives the execution priority to the highest priority task which is configured in the application. So that is what we mean by preemptive. Okay, so the second one is the kernel is a deterministic, which means it should be a time bounded, like within a specified time it should execute the particular task, or it should process the particular ISR. That means it supports the hard real time. Okay, and the third one is the kernel is a event driven. That means any configured ISR or the user calls to the APIs. APIs are nothing but TIRTOS APIs will invoke the scheduler. Okay, that is what mean by the event driven. And the last one is the kernel is an object based. Okay, so all the operations are self-contained, so the change in the one object will not affect the other configured objects. So that means TIRTOS will provide the API calls based on the object. Okay, so suppose whenever you want to create a task, again you need to create a task object to the particular task. Okay, and then you create a task. Okay, and then similarly for semaphores, you create an object and use that object to define some parameters of a semaphore. Okay, so and so the task object will not affect the semaphore objects. So that is what it mean by the all operations are self-contained. Okay, and so TIRTOS will provide the three ways to create the TIRTOS kernel objects. Okay, so the first one is the statistically create. So the statistically create means using a xzconfig GI tool. Okay, the statistical configuration is always based on the GI tool. Okay, and there is some script is also associated with that GI tool. Okay, I will show you later how we can use this GI tool to configure the or create the tasks or semaphores and all. Okay, even for the memory management also. Okay, this is one method of creating the TIRTOS kernel objects, and the second one is the dynamically create. Okay, so the dynamically creation means we should use the TIRTOS APIs to create the objects and also to create the necessary parameters required for a particular task or semaphore. And there is one more mechanism called dynamically construct. So this method also uses the TIRTOS APIs, but there is a small difference between the dynamically creation and with respect to the dynamically construct. Okay, and so I'm going to explain these differences in the later tutorials. Okay, but all the examples which are provided by the TIRTOS, okay, which will use the dynamically construct, but in this tutorial or in this series of tutorials I'm going to use the dynamically create method to create the TIRTOS kernel objects. Okay, so everyone every method has its own advantages and disadvantages, and it up to the application engineer to choose the which method to proceed. Okay, so going forward, so what are the different TIRTOS kernel features? Okay, so the scheduler, TIRTOS kernel provides a scheduler based on the scheduling algorithms. So preemptive scheduler that guarantees the highest priority thread is running. Okay, and apart from the preemptive scheduler, so it will also provides the time slicing. So that also we can see later. Okay, and then coming to the next point, that is a communication mechanism. So it is also supports the inter-process communication. Let's say for example you have a two tasks and you want to communicate between the one task to another task, or you okay based on a particular action or a flag you want to pass, or you want to put a one particular task into block mode, or you want to enable one particular task from the block mode to the enable mode. Okay, in order to execute it by the kernel. So you can use these communication mechanisms, also called as inter-process communication mechanisms. Okay, so those are basically semaphores. Semaphores again contains two kinds of semaphores. One is a binary semaphore, another one is a counting semaphore, and then you have another method called message queues and etc. Okay, and then there are special things to manage the critical regions in the application. So that can be achieved using the mutexes, gates, and logs. So basically, mutexes means mutual exclusion. Okay, for example, if you want to get the data from the two eyes 2C devices, okay, so you can always use the mutexes to mutually differentiate between the one I2C device to the another I2C device to avoid the conflicts in the data reading. Okay, and we will also see what is gates and logs, etc. Okay, and it also provides the timing services, so namely clocks and the timers. Okay, so we use the clocks, and there is one API called a task underscore sleep, so which will actually put a one particular task into the block mode. Okay, so you can use that, and also you can use the timers to generate the software interrupts. We will talk about what is the software interrupts a little later now. And then coming to the power management. Okay, so for low power devices, power management is generally part of RTOS since it knows the state of the device. Okay, so throughout this series of video tutorials, I'm going to use two boards. One is the MSP432P401R launchpad, which is based on the Simple-Link SDK, and the other board that I'm going to use the Tevasi TM4C123GXL board. Okay, and both are ARM Cortex M4 devices. Okay, so but if it comes to the MSP432, it's basically a low power device. So then TIRTOS will also handles the low power modes. Okay, I will also show you how it is actually adding to the TIRTOS kernel, and where actually they are executing this low power management related functions. Okay, so then coming to the memory management, so of course TIRTOS or any RTOS should support the memory management. So you can use the variable sized heaps or fixed size heaps. Okay, and basically we use these heaps to dedicatedly use for the TI tasks. Okay, okay, and then peripheral drivers. Drivers, that means the TI drivers are common across the all simple link devices. Okay, even I'll show you how to use the TI drivers for the Tivasi, because Tivasi is not comes under the simple link SDK. Okay, but MSP432 is a simple link supported device. Okay, and then coming to the protocol stacks, it also supports the BLE, Wi-Fi, etc. Okay, if your board is having a BLE or Wi-Fi, so you can use that in the TIRTOS. Okay, TIRTOS do supports this. And then coming to the file system, so it supports the FATFS, and the device management, exception handling, boot, etc. Also the TIRTOS will take care of it. So these are the different features of the TIRTOS kernel on a high level view. Okay, let's move on. TIRTOS threads. TIRTOS provides four basic threads. Okay, so namely ideal, which is also called as a background task, and the task. Okay, and the SWI is nothing but the software interrupts. HWI means the hardware interrupts. So the nomenclature goes like this. Okay, and the priority also, you see, it increases from the ideal task to the hardware interrupts. Okay, so hardware interrupts will be treated as high priority things in the TIRTOS, and ideal task or a background is also one particular task. So when it comes to hardware interrupts, okay, it triggers the who to run. Okay, and BIOS will handle the context save and restore and also the function nesting. Okay, hardware interrupts triggers the follow-up processing. Depending on the device, priorities may be configurable. Okay, so you can also configure the priorities. Okay, so let me, you have, if you have a two hardware interrupts, you can also give priority to these two hardware interrupts, which one need to execute first. So then when it comes to the software interrupts, okay, so basically software posts this suite to run. Okay, and then we'll see posting means like it will hand off kind of thing. Okay, and performs hui follow-up activity. Okay, and then it supports up to 32 priority levels. Okay, 16 on the C28X and MSP432 devices. So when it comes to task, as I said earlier, also task is a very basic entity of any RTOS. Okay, so you can use the task to run your application concurrently. So you can define two tasks, and then you can run these two tasks independently. Okay, and how you can do that is, one you can block and another one you can execute, something like that. Okay, and then you can also give the priorities to that. Okay, so basically it will be enabled to run by posting the semaphore. It need not to be the case, but usually people used to use the semaphore to enable the task, but you can also run the task individually, and it supports up to 32 priority levels. Okay, but 16 on the C28 and MSP 430. Okay, and that's all about the task. We will see in detail about the task or all these threads in the upcoming tutorials. And then coming to the ideal task. Okay, so as I said, it's basically a infinite while loop. Okay, and it will execute when there is no other tasks or SWI or hui. Okay, that means hardware interrupts or software interrupts or tasks are not running by the or your microcontroller. Okay, so there is a provision also here. Okay, you can also assign multiple functions to the ideal function, and it will execute one after the other, and of course it's a single priority level. Now let's take a typical use case, how TIRTOS will execute the task. Okay, based so as I said, we are going to use the preemption scheduling mechanism. So you look at this timing diagram. Okay, so you in the left hand side in the y-axis you see we have the ideal task, which is also known as a background task. We have a software interrupt B, software interrupt A, hardware interrupt 2, hardware interrupt 1. So hardware interrupt 1 is a high priority than the hardware interrupt 2. Okay, and the software interrupt B is high priority, low priority than the software interrupt A. Okay, so at this time slot when there is no other task is running by the your microcontroller. Okay, so then the idle task will execute. Okay, and eventually you see at this point of time we see a software interrupt occurs, and then kernel will jump to this and it will execute it. And while it executing it, it sees that okay, there is a high priority hardware interrupt occurs. Okay, that is HWI2. So then kernel will be preempted to this. Okay, and it will execute it. Okay, you see while executing the hardware interrupt. Okay, at this point of time the software interrupt A is in ready state. Okay, so usually if it is in ready state, the RTOS should actually enable, like bring, like should be able to execute this also. But as I said, it's a preemptive kernel. Okay, preemption based algorithm, right? So always it runs the high priority task, so it will not run, it will be in ready state only. Okay, and at this point of time it sees that again hardware interrupt 1 occurs, and it will execution will again switch to here, and it will execute the hardware interrupt 1. Again it will be come to the hardware interrupt 2 because that is the next high priority, and then it will execute, and then again it comes to the next priority task. So the next priority task that we see is the software interrupt here, though it is ready at this point of time, but it is not executed by the kernel. So that is how the TIRTOS ensures that high always high priority task will run. Okay, and then it will switch from the ready state to the running state. Okay, and then again it will switch to the software interrupt B. After the execution of the software interrupt B, at this point of time there is no other tasks running by your microcontroller or your processor, so it will be switched to ideal task. So that's all about this tutorial. So in this tutorial we have seen what are the different features of the TIRTOS, what are the different threads that a TIRTOS can be provided. So in the next tutorial I'm going to show you how to install the tools, okay, which are required for the TIRTOS, okay, both for MSP432 as well as for the TIVASI. Thanks for watching this video tutorial. If you like this video, please do subscribe to my channel. Thank you.